Hi, Mr. Minnick here, helping my students learn Python and specifically how to use control expressions. You should all understand what's called the truth table. The truth table is a chart that helps you understand whether control expressions, complicated control expressions, are overall true or false. So let's just understand that usually you have two variables, and I call them A and B, even though some teachers call them P and Q, but that's not me. And there are four possible patterns that you can use to fill in your two variables A and B. In the world of binary, there are only zeros and ones. Those are the only numbers that can plug into those two variables. So 0, 0, 0, 1, 1, 0, 1, 1. And I always write them out in that order, and not like the 1, 1 at the top, and then the 0, 1, 1, 1 with the 0, 0 at the bottom. Some teachers like to do it that way. I'm fussy. You must recite this on a quiz eventually in this order. You see, you're really counting in binary. In binary, the number 0 that you're used to is equal to 0. The number 1 that you're used to is also 1 in binary. The number 2 that you're used to in binary, it's 1, 0. And the number 3 that you're used to in normal math, in binary, it's considered the number 1, 1. Now, if you fill in the leading zeros there, right here, this is really just counting in binary. 0, 0, 0, 1, 1, 0, 1, 1. So it's like going from 0 to 3. That's one reason why I like to always list these ordered pairs in that order. Well, anyway, if you do make these two columns correctly for a full credit on a quiz, then I want you to consider what would happen if your strict parent, everybody has a strict parent and let's say an easy parent. If strict parent, S, strict parent, says you only get dessert if you do eat your asparagus and you eat your broccoli. Well, there's always a kid in every family of quadruplets that doesn't eat anything. His name might be Patrick. He's picky, doesn't eat asparagus, which means false, 0, and he doesn't eat broccoli. Does strict parent allow him to get his dessert? No way. False. No soup for you, kid. Okay, there's always a kid that, well, he's a little picky, and we'll say that his name is Matthew. Matthew, you do not eat asparagus, but you do eat broccoli. Would the strict parent allow you to have the dessert? False. He's shaking, just for the record, everybody, he's shaking his head no. Correct. Okay, there's always a kid who likes asparagus but not broccoli. That kid is Dalton. Dalton, would you get your dessert from strict parent? False. He's saying false. Now, there's always the goody two-shoes kid. The kid who's, eats organic vegetables and may not eat meat, but eats vegetables for sure. That student is, we'll say, Tim. Tim, do you get dessert? Yeah, because you eat everything. So, Tim. Okay, well, strict parent left town, and now easy parent is in town. Let's pretend that never happened before. Hey, Patrick, do you get your dessert if easy parent says, oh, you can have dessert if you eat either asparagus or broccoli? Patrick, do you get dessert? No way, because you don't eat anything, not even with easy parent. Matthew, do you get dessert? Yeah, he does. See, he won because he did eat at least one thing. I kept easy parent happy. Dalton? Yep, he says true. And Tim? Definitely. So this is the world famous truth table. Really, it just shows that what the word and the word or means in the English language when you have yeses and nos or trues and falses on either side of the word and or. Now, before I move ahead, I do want to stress something about this truth table. In the truth table, the operation and is similar to multiplication. Because check it out. 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. And 1 times 1 is 1. So to the world of George Bull in the 1800s, when he figured all this out, he thought that the word and was like multiplication. And it is true to electrical engineers and anybody who goes into computer engineering and designs circuit boards and computer chips. The word and is similar to multiplication. Okay, the word or. What mathematical operation is the word or similar to if multiplication is really like an and? Ideas? Patrick? What? Good answer. Usually people say division, and they're wrong. But yes, good, addition. Here goes. Let's double check. 0 plus 0 with easy parent check is still false. 0 plus 1 is 1. 1 plus 0 is 1. And 1 plus 1. In the world of binary, in the world of digital stuff, if something's on and it's just the light switch is flipped up again even though it was already in the on state, it's still on. There is no 2. There is no like extra bright on your bedroom light. We're not talking about dimmer switches here. That's like beyond the scope of this lesson. So it's perfectly normal to George Boole and computer electronics, digital electronics, that 1 plus 1 is really 1. If the gate's open and you make it open, it's still open. Okay, so remember, multiplication comes before addition in the order of operations. So on one of the exercises that we're about to look at on this worksheet, you have to remember that you always do ands first before ors, unless there are parentheses.